Have you ever stopped to wonder what really makes an operating system like Linux tick? It's way more than just lines of code. It's a whole set of invisible rules. Today, we're going to pull back the curtain on those rules by looking at the 3 pillars that control absolutely everything in the system: people, time, and place.
I mean, just picture a massive cloud server. How on earth can one single computer serve thousands, maybe even millions of people all at once without just collapsing into total chaos? That's the million-dollar question, and it's the core problem Linux was built to solve. We're going to break down exactly how it pulls it off.
Well, it all starts with the core idea behind Linux, what we call the multi-user challenge. From day one, it was designed to be used by lots of different people at the exact same time. But that simple idea? It creates a massive challenge.
Because when you have a ton of users on one system, you've got a huge problem on your hands. The system has to figure out who gets access to what, keep everyone's private data secure from everyone else, and make sure that all the computer's resources are shared fairly. Without a really powerful system of control, it would be a total free-for-all.
Okay, so how does Linux actually prevent this chaos from happening? Well, it all rests on 3 fundamental pillars of control. Let's start with the first, and you could argue the most important one: how it manages the people using the system.
The whole thing boils down to a concept that's incredibly simple but completely brilliant. Every single person who logs into the system gets their own unique digital ID card. This is what we call a user account, and it's the system's way of knowing exactly who you are and what you are and are not allowed to do.
And here's the really clever part. That digital ID is stored by splitting it across 2 different files, all for maximum security. The first file, /etc/password, is kind of like the public part of your ID card. It has your username, your user ID, stuff anyone on the system can see. But the second file, /etc/shadow, is top secret. Only the system administrator, the root user, can read it because it holds your heavily encrypted password. So why separate them? It's a critical security feature. If a hacker somehow got their hands on that public password file, they still wouldn't have the passwords, which makes breaking into accounts so much harder. It's a simple but incredibly effective design.
So, creating one of these digital IDs is basically a 3-step dance. First, an administrator uses the user add command to create the basic account. Next, they use the password command to lock it down with a secure password. And then, anytime later, they can use usermod to tweak any of the details, like changing a user's name or what programs they can run.
All right, so managing individual users, that makes sense. But what happens when you have whole teams? A marketing team, a software development team, an accounting team. You can't possibly manage permissions one person at a time. That would be an absolute nightmare. So how do you handle permissions for entire teams?
The solution is just so elegant: groups. The best way to think of a group is like a digital club membership. If you're a member of the marketing club, you instantly get access to all the files and resources that are reserved for that club. It's a super simple but incredibly powerful way to manage access for lots of people at once.
Okay, so we've got a handle on who can access the system. But what about when things happen? This brings us right to our second pillar: controlling time. This is all about automation, making the computer work for you even when you're not around.
There's this old saying that a great system administrator is a lazy one. And what that really means is that they're smart enough to automate everything they can. They definitely don't want to wake up at 2 in the morning just to run a backup. Nope. They want the computer to do it for them automatically. And that is the whole essence of controlling time.
The classic tool for this is something called Cron. Now, I know the syntax looks a bit intimidating, but the idea behind it is actually really simple. You just tell it a minute, an hour, a day, and so on, and then you give it the command you want it to run. So the example we see here is telling the system to run a backup script at 4:30 a.m. every single day without fail. You set it up once, and it just runs forever.
Now, here's the crucial part. You've got to choose the right tool for the job. For tasks that repeat over and over again, like those nightly backups, you use Cron. But for a task that's only going to happen once in the future, like say rebooting a server tomorrow morning at 2 a.m., you use a totally different tool called @. It's all about repetition versus a single one-off event.
So we know who can use the system and when tasks can run by themselves, but what about where all these users are? This leads us to our final pillar: controlling place. How can a single computer give a perfectly normal experience to users all over the world?
The answer is a really cool concept called a locale. And honestly, the best way to think about a locale is as the system's own personal cultural translator. It's just a set of rules that tells the computer how to behave for a specific language and country, whether that's in Germany, Japan, or Brazil.
And a locale changes all those little things that you probably take for granted. It sets the language for all the menus and error messages. It decides if a date should be written month, day, year, or day, month, year. It even changes the currency symbol and whether you use a comma or a period for decimal points. Basically, it makes the system feel completely local, no matter where you are in the world.
But wait, how does the system not get totally confused by all these different time zones? Well, it has a secret language for time, UTC, or Coordinated Universal Time. The server's main clock is always set to this one global standard. Then it just looks at your personal time zone setting and translates UTC into your local time on the fly. This is how someone in London and someone in Tokyo can look at the very same file and both see the correct local time for them.
And the absolute magic that handles every single character from English to Chinese to, yes, every single emoji you can think of is a standard called UTF-8. You can think of it as the universal alphabet for computers, and it's what makes our modern global communication even possible.
All right, so let's pull all these ideas together and take a look at the big picture, the very foundation of the system.
People, time, and place. These three pillars of control, they aren't just some boring technical details, not at all. They are the invisible foundation that makes so much of our modern technology work.
I mean, really think about it. From the huge cloud servers that are powering your favorite apps right now, to the smartphone in your pocket, which is almost certainly running on Linux-based technology, this elegant system of order is what allows it all to work securely and reliably for billions of us every day.
So it all comes down to mastering who can do what, when they can do it, and how the system is presented to them. That's really the secret sauce of system control. And it makes you wonder, doesn't it? What other invisible rules are out there quietly governing your digital world every single day?